Hello students, so in this video I'll be discussing the later part of the chapter Matter in Our Surroundings, the first chapter in class 9 chemistry in CRT book. So here we'll be discussing the concept of latent heat, conversion of temperature between Kelvin and degree Celsius, and the concept of evaporation. So suppose we take a beaker containing water, normal water, and we place a thermometer in that beaker. After that, so under the normal condition, the temperature of the thermometer will show room temperature. After that, we start heating the water. What we will observe, as we keep on heating, the temperature in the thermometer will keep on rising. More we will heat, more the temperature will rise. But as soon as the temperature reaches 100 degrees Celsius, which is the boiling point of water, at this moment water will start to boil. So as water starts to boil, we will observe a very interesting phenomenon. Though we will be heating it, but the temperature will remain fixed at 100 degree. It will not go beyond 100 degree. So the question arises is that where does the heat goes? The heat that we are supplying, why it is not showing in the change in temperature? Now that heat which is not shown in the change in temperature, it is used to overcome the interparticle force of attraction, because water is liquid. In liquid state, the interparticle force of attraction is more compared to the gaseous state. So an extra amount of heat is absorbed to overcome that interparticle force of attraction, so that the water can change from the liquid state to the gaseous state. So that is the concept of latent heat. Similarly, we can take the example of melting of ice. Suppose we take some crushed ice in a beaker. We take a thermometer showing room temperature. When we'll put it into the ice, slowly the temperature will keep dropping. And very soon, as soon as it will reach 0 degree, we will find that the ice is melting. But ice is melting means what? The ice is taking heat from the surrounding. Though it is taking heat from the surrounding, that means what? The temperature should have risen, but the temperature does not rise. It remains fixed at 0 degree. That means where this heat is going, which is being taken from the surrounding, it is being used to overcome that interparticle force of attraction. So the question is, how longer the temperature will not rise? It is till the entire volume has not converted its state. This ice, the temperature will remain fixed at 0 degree until and unless the entire ice does not melt into water. After that only the temperature will start to rise. So what we have, so what is latent heat? It is the hidden heat which is used to overcome the interparticle force of attraction during change of state without change of temperature. Heat will be absorbed but no change of temperature under normal condition. There are two types of latent heat. One is latent heat of vaporization. Another one is latent heat of fusion or melting. What is latent heat of vaporization? It is the hidden heat which is required to completely convert 1 kg of liquid into gaseous state without change in temperature. So 1 kg of liquid. Now some of you may be thinking that how can we get 1 kg of liquid? Suppose you take a bucket of water, place it on a weighing machine, you'll get the weight of that water or not. So liquids we measure liquids in volume, in liter and all, we'll measure the volume, but liquids also have mass. So 1 kg of liquid. Latent heat of fusion or melting, it is the hidden heat which is required to completely convert 1 kg of solid into its liquid state without change in temperature. So in both the cases, temperature is not going to change. That heat, that's why it is called hidden heat, because it is not expressed in the change of temperature. So generally, in our day-to-day use, we use the unit for temperature that we use is degree Celsius, and the SI unit of temperature is Kelvin. So what is basically the relation between degree Celsius and Kelvin that we are going to see here? So if we see here, this is the beginning point. If you remember this, you can remember the whole thing. 0 degree Celsius is equal to 273 Kelvin. Actually 273 point something, but we can take it as 273. Now for every degree rise in degree Celsius, there will be every degree or 1 degree rise in the Kelvin scale. Suppose when it is 1 degree Celsius, it will become 274. When it is 2 degrees Celsius, it will become 275. When it is 3 degrees Celsius, it will become 276. Similarly, if we come downward, minus 1 degree Celsius will be 272, minus 2 degrees Celsius will be 271. So 1 place change here. Here also there is a difference of 1 each. Now this 274, I can write it as 273 plus 1 Kelvin. 275 I can write it as 273 plus 2 Kelvin. 276 I can write it as 273 plus 3 Kelvin. That means what? With 273, if we add the degree Celsius, we'll get the Kelvin scale. So suppose we go on and we take x degree Celsius. So how can we convert it into Kelvin? Just add 273. Now if we come downward, this is decreasing. So a time will come when it will reach 0 Kelvin. So 273 Kelvin becoming 0 Kelvin. So 0 degree Celsius will become how much? Minus 273 Kelvin. So minus 273 degree Celsius. So this minus 273 degree Celsius, this is the lowest achievable temperature and it is called absolute zero. So this is one thing we have to remember. So how do we convert degree Celsius to Kelvin? The whatever degree Celsius will be given to it, you add 273 to it and that will give you the Kelvin scale. And if you have to do the reverse, Kelvin to degree Celsius, whatever Kelvin is given, from that you minus 273. Don't suppose it is given 100 Kelvin. So 100 is less, so don't end up making 273 minus 100 because subtraction is not commutative in nature. Addition is commutative, you can put 273 in front. But here x Kelvin, whatever Kelvin is there, from that you have to minus or subtract 273. So here are two sums I have given here. So you try to do it. Convert the following into Kelvin: 100 degrees Celsius, 110 degrees Celsius, minus 10 degrees Celsius, minus 27 degrees Celsius, minus 27 degrees Celsius. And second one, convert the following into degrees Celsius: 300 Kelvin, 283 Kelvin, 250 Kelvin, 100 Kelvin and 520 Kelvin. So after this, we'll be discussing the concept of evaporation. Now normally we have seen, suppose we place a wet piece of cloth or your clothes, wet clothes outside in the sun. Will the water boil inside the clothes or it will evaporate? So obvious answer is that they will evaporate. The water will evaporate. It's not going to boil. So evaporation is also change of water into water vapor. Boiling is also change of water into water vapor. So where lies the difference? There are much differences. We'll come to talk about that later. Evaporation is basically a surface phenomenon. It takes place from the surface. So molecules at the surface will get converted into the gaseous state. And to convert, they have to overcome, the lower particles will be attracting these particles, so they have to overcome the force of attraction. So they will need some heat or energy. From where they will take the heat? They will take the heat from the surrounding. Either from here or from here they will take the heat. As they take the heat, the surrounding will cool down. So evaporation leads to cooling. So how can we define evaporation? It is the process of conversion of liquid state to gaseous state at any temperature below the boiling point of that particular liquid. Next we come to the factors which affect the rate of evaporation. There are different factors which affect the rate of evaporation. First is temperature. So we know the hotter the day, the faster the clothes will dry out, because more energy will be available for the liquids to escape as vapor in the vapor state. So higher the temperature, faster is the rate of evaporation. Second factor is surface area. So we know when we put clothes in the sun, in the clothes line, we spread out the clothes. Why do we do that? So that the surface area is more and more easily the liquid is able to vaporize. Similarly, when your father is in a hurry to go to office and the cup of tea is quite hot, what your father or mother does when they are in a hurry to sip that cup of tea, they pour it onto a saucer, because in a saucer what happens, the surface area is more compared to that of a cup. So faster will be the evaporation, and I have told you evaporation leads to cooling. Wind speed. So suppose your uniform is dirty and your mother washes the uniform. Overnight she will keep it under the fan. So faster. So what happens when the wind is blowing? Suppose this is the surface of the liquid and there are water vapor. Suppose this is the level of water and these are water vapor. So when wind will blow, the wind will carry away the water vapor and more water can vaporize as water vapor. So faster the wind speed, faster is the rate of evaporation. Fourth factor is humidity. Humidity means the amount of water vapor present in air, or moisture what we say. So whenever the humidity is quite high, the rate of evaporation becomes very less. Why? Suppose a room is filled with people. It will be difficult for you to enter. But if the room is relatively empty, it is easier for you to enter. Similarly, suppose above the surface of the water, humidity is very high. There are lots of water vapor. So it becomes very difficult for the water to vaporize as water vapor. So your higher the humidity, slower is the rate of evaporation. Fifth factor is nature of the liquid. This is not mentioned in the book. So nature of the liquid means whether your liquid is you can say a volatile liquid or it is a viscous liquid. Now suppose we take this to example. Suppose in a bowl I keep petrol and in another bowl I keep water, or if you haven't seen petrol, you can take the example of nail polish remover. So which will evaporate faster? Obviously it is nail polish remover, because the interparticle force of attraction among the molecules is less. So by taking little heat they can easily vaporize. Such liquids are called volatile. Petrol, nail polish remover, alcohol, ethanol, all those are volatile liquids. And viscous liquid, very thick. Suppose honey. Now if you keep in a beaker, in two bowl, one you keep water, another you keep honey. Obviously after few days you'll find water has evaporated but honey has remained there, because it is viscous, it is thick, interparticle force of attraction is more. So more volatile the liquid, faster is the rate of evaporation. So here I have stated the differences between boiling and evaporation. If you can add more, it's better. So boiling, now this is in general. Don't make the mistake of writing that boiling occurs at 100 degree. That's the boiling point of water. So different liquids have different boiling point. Like alcohol has a boiling point of 78 degrees Celsius, that way. So boiling point, first point, boiling, it occurs at a fixed temperature called boiling point. Evaporation, it occurs at any temperature below the boiling point. Next, boiling, it is a bulk process. Bulk means the entire thing. Suppose when you are boiling water to make tea, the whole water keeps on moving, circulating. That's called the bulk process. The whole mass is involved. Evaporation is a surface phenomenon. Boiling, it does not cause cooling. Evaporation, it causes cooling. Boiling, a definite amount of heat called latent heat is absorbed. So during boiling, latent heat of vaporization will be absorbed by the liquid. And evaporation, the heat will be absorbed, no doubt, but the heat absorbed from the surrounding is not the latent heat. It's not called the latent heat. So don't make that mistake of labeling it as the latent heat. So some examples are there which we can discuss out here. Like cotton clothes are preferred in summer. We know that in summer season we prefer cotton clothes. Why? Because cotton absorbs the sweat and it will bring the sweat to the surface, which will evaporate. While evaporation, heat will be taken from your body and you will feel cool. Similarly, desert coolers cool better on hot dry day. So desert coolers means actually air coolers. You know how air cooler works. We have to put water, and when you switch on the fan, the water will evaporate. While evaporating, it will take the heat from the surrounding and it will make the air cool. So why desert cooler cools better on a hot dry day? Because on a hot dry day the rate of evaporation will be faster and better will be the cooling. Therefore you find air coolers, they have a much better effect in cities like Delhi, but in cities of northeast like Guwahati, the effect of desert coolers are not so much. So why? Because here in northeast the humidity is quite high, the rate of evaporation is much lesser, so cooling is not so effective. Next, water kept in an earthen pot remains cool. So you have seen earthen pitchers. Earthen pitchers, they have fine pores. So through those fine pores, the water will seep out. It will evaporate at a very slow rate. While evaporating, it will take the heat from the water and the water inside remains cool. Similarly, we spread out our clothes for drying. I have already told you to increase the surface area so that the rate of evaporation is faster and the clothes dry faster. Similarly, there are other relatable questions from the chapter which we have already discussed. One very common question is, which causes better cooling, ice at 0 degree or chilled water at 0 degree? Now the answer is ice at 0 degree. Why? Temperature of both are same, but ice, when it will melt, it will take an extra amount of heat from the surrounding and or from the surface, and that extra amount of heat is in the form of latent heat of fusion. Therefore ice will cause a better cooling, but chilled water already has that latent heat of melting or fusion in it, so it will not absorb that extra latent heat. So cooling effect of ice will be better. Similar is the reason which causes severe burn: boiling water at 100 degree or steam at 100 degrees Celsius. Temperature is same for both, but steam at 100 degree will have an extra amount of heat in the form of latent heat of vaporization. So that will give you a more severe burn because of that additional amount of heat. Boiling water does not have that additional amount of heat, but however, for practical purposes, both will give you very severe burns. So be careful. Similarly, like another relatable question from the before aspects which we have discussed, the properties of matter. So why smell of hot food reaches to longer distance? Because we know hot food, the smell particles, they will have more energy. When they will have more energy, they can travel to longer distances. So more or less, these are the things which have been mentioned in your book. So you go through the entire video, you pause the video, make necessary notes, and if you have any doubt, you can revert back. So just check my other videos on the YouTube link. Thank you.